collection of support vector machines for text classification or natural language processing. The task is that given a collection of news articles, these news articles are of two types. One is technology and the other is religion. So given these two types of news articles, you have to use support vector machines and be able to classify any article as either technology or religion article, and you have to use the bag of words classification approach, and that's it, and support vector machines. So the first step, so to summarize the steps that we are going to follow, these are: first we will collect data, then we will prepare data, then we will apply the model, choose model of SVM, then we will train SVM, then we will test the support vector machine. These are the steps that we are going to follow. First step, we will import the library functions, and just to give a background, there are three types of support vector machines: linear, new, and C support. So these are for even classification as well as regression. We will use the linear support vector machine, and since it is classification problem, it is the linear SVC, that class that we are going to import. So first, load the dataset. This is a Scikit-learn function using which you can load multiple news articles, multiple categories of news articles, and we are going to choose the first two categories. That is why I have written atheism and computer graphics. Then we have to then we can check the number of articles of each category, and in this data there is no missing value, no duplicates. That is why we can directly go for splitting the data. I am splitting the data into 80% for train and 20% for test. And then we will apply tokenize and vectorize. So you can recap tokenization. This is the unigram and bigram, both we are going to use, and followed by the TF-IDF vectorizer. So I have imported the TF-IDF vectorizer. In this I have given n-gram as unigram as well as bigram. So this is unigram and bigram both. The integer type tokens will be generated, and then we are going to use the UTF-8 encoding. Any errors will be replaced and any accents will be changed, and we are using the word level encoding. So with this, here we are getting the TF-IDF results for each sentence in the data set. So if you want, you can check what is the original sentence, for example X train and 0. So this is the original data set which has the news article, and we have converted that. See, this is the TF-ID, this is the tokens, and further we have, this is the token number, and further we have converted them into the vector form, TF-IDF vector. After vectorization, we, for the 74924 tokens in our data set and 1417 samples in the data set, we have tokenized and vectorized. Ideally, we don't need so much data. We can select the top 25,000 tokens and work with them. So I have used the feature selection technique and extracted top 25,000. Hello and welcome back to the support vector machine implementation using Scikit-learn. So in this, right now we have completed the feature selection and we have extracted the 25,000 features. Next step, you can just see what is the size of the train and test set. There are 25,000 best features selected. Now I go to the Scikit-learn website and choose the linear SVC. This is the linear support vector classification. This support vector classification has these parameters. Then with this parameter list we have to copy, go to ChatGPT and we have to type, give us the grid search for the below parameters and code. Here I have given the ChatGPT prompt, and then you can see it has the parameter grid. And then we are applying the estimator, performing grid search, fitting on the train set, and then getting the prediction on test set, and finally we are calculating the metrics on the test set results. So this is how we have applied the linear SVC support vector classification on data, and we will see more details in the next video. Thank you. Back to support vector machines. Today we will see the implementation of support vector machines on a text classification sentiment analysis dataset. This dataset comes from the website Rotten Tomatoes, which is of movie reviews. Essentially, it is about classifying the movie reviews as negative, somewhat negative, neutral, somewhat positive, and positive. That means it is a multi-class classification. The training set is very large, 1,24,848, and test set has 31,212 samples. So initially we unzip the data set. Further we get the train and test set. You can see the train set as this question and the sentiment associated with it. Then we extract X and Y. We split the data set into train and test, and then we can go for tokenization and vectorization. Since the data set is very large, to speed up the processing we use only the top 250 features, which means the train set has 124,848 by 250 and the test set has 30,000 by 250 samples. Then I have spoken before that this is a classification problem. Particularly it is a multi-class classification problem because there are more than two classes. Okay? Classification is of two types. It has binary and multi-class. So binary has just two classes and multi-class has more than two classes. And that is why, since this problem has more than two classes, that means it is a multi-class classification problem. We can use either the linear support vector classification, the new support vector, or the C support vector. So these are the parameters of the support vector machine, linear SVC, and I have given ChatGPT the prompt that perform grid search and give code. So ChatGPT has given me this parameter grid for testing on the linear support vector machine, and based on that, we have applied on the train set and further test on the test set and get the evaluation metrics. So This is how we do the steps. I will summarize here what are the steps. So first step is the loading the data, or I will call it data collection, and we can say loading into Python pandas data frame. Then there is the second step, which is about data preparation. So data preparation involves tokenize, then vectorize, then standard scalar, feature selection. Before that comes the standard scalar, which is also called as rescaling the data. Optionally, we can perform feature selection. Here we will also write split into train and test. This is important before we tokenize. Another thing that we should remember is, before we split into train and test, we should check for duplicates and remove. We should also remove corrupt data. That's it. Then model selection. So here I have chosen the linear SVC, or you can also choose the new SVC or the C support SVC, any of these. And then in model selection we also do the grid search, which is hyperparameter tuning. Because see, you should be familiar with the term hyperparameter tuning. I was saying hyperparameter tuning was done in the previous videos. After that, model evaluation and calculate the performance measures on the test set predictions. So another data set on which you can try, which also we have given to you, is the IMDb sentiment analysis dataset. So this dataset is about IMDb movie reviews. However, it is simple because there is only the negative and positive, just two kinds of classification. So it is a binary classification problem. Also, the size of the dataset is considerably smaller. There are around 25,000 examples in the train set and 25,000 in the test set. So we have given the one sample example. First we download the data set. Okay, so the steps are same. What we have done here, these steps remain same. I will just copy paste them here. First is the data collection. So this is data collection, that is downloading from the source and load into pandas data frame. Pandas data frame is the preferable way of storing and manipulating data. Then we read the data set. So the data set is present in multiple files. We read it. One sample sentence written in the data set, just to show you. See, this is a wonderful film, and spectacle. So this is definitely a positive comment. And y has 0 and 1. 1 is for positive, 0 is for the negative. So we shuffle the data set. Then we split it. Already it is split, so no need of splitting into train and test. We just tokenize, vectorize the data set, and after tokenizing and vectorizing, we can perform feature selection to reduce the dimensions. We take the 25,000 features. This number can be anything. You have to try different values and decide what should be the best feature selection. And for this also I have used the linear SVC. So there are the three types of support vector classifiers. I have taken the linear support vector classifier, and this is the parameter grid. This remains same. We have then tested, trained, and further we have tested, and then we have calculated the different metrics. So in general it is doing really well on the data set. Around 90% is the F1 score. That is very good. Further, I have spoken about how we can deploy this and launch it in the form of a website. If needed, you can check out this code as well. Okay, so that was it about linear vector classification. So we will be giving you this notebooks where you can practice on and see the code and also practice. You can leave any questions that you have below the video, or you can contact us by phone or WhatsApp or email, and we will be happy to guide you. So good, thank you for working on all these different technologies with us on multiple domains, and next there are some capstone projects for you to practice. Okay, so best of luck with that. Thank you for watching.